Caloric restriction, a sustained, moderate reduction in calorie intake without malnutrition, has emerged as one of the most consistently effective interventions for extending lifespan and delaying the onset of age-related diseases in a wide range of organisms, from yeast and worms to mice and monkeys. Central to this powerful anti-aging effect is autophagy, which caloric restriction robustly activates. When nutrient intake is limited, cells enter a resource-conserving mode, triggering autophagy as an adaptive response to recycle internal components and maintain energy balance. This process doesn't just keep cells alive during times of scarcity, it fundamentally rejuvenates them by removing damaged organelles and proteins, enhancing overall cellular health. The activation of autophagy under caloric restriction has been shown to delay multiple hallmarks of aging. By efficiently clearing out dysfunctional mitochondria, caloric restriction reduces the production of reactive oxygen species and maintains optimal energy generation, preserving the function of tissues like brain, heart, and skeletal muscle. This helps explain why caloric restriction has been associated with extended lifespan and health span across species, including dramatic increases in longevity in laboratory animals. Moreover, caloric restriction-induced autophagy limits the accumulation of cellular waste products such as lipofuscin, an indigestible pigment that builds up with age, thereby maintaining cellular clarity and function. In the nervous system, this helps prevent the formation of protein aggregates linked to neurodegenerative diseases, supporting cognitive health deeper into old age. In the immune system, caloric restriction preserves the regenerative capacity of hematopoietic stem cells, sustaining immune surveillance and reducing vulnerability to infections and cancer. Importantly, caloric restriction also improves metabolic health by enhancing insulin sensitivity, lowering blood pressure, and reducing systemic inflammation, effects largely attributed to improved cellular housekeeping through autophagy. This multifaceted benefit suggests that autophagy is not simply a survival response during caloric restriction, but a proactive strategy cells use to optimize performance, repair accumulated damage, and resist the functional decline that typically accompanies aging. The promise of caloric restriction extends beyond animal studies. While long-term human data are still emerging, shorter-term trials show that caloric restriction improves markers of metabolic health, reduces inflammation, and increases expression of autophagy-related genes, indicating similar underlying mechanisms may be at play. Additionally, compounds that mimic some of the effects of caloric restriction, like spermidine and rapamycin, are being explored for their ability to activate autophagy and reproduce some longevity benefits without the need for extreme dietary changes. Ultimately, caloric restriction's ability to activate autophagy reveals a profound truth about aging. By occasionally limiting energy intake, we encourage ourselves to invest in maintenance and repair rather than unchecked growth and accumulation of damage. This shift supports more efficient resource use, greater resilience, and a remarkable extension of both lifespan and health span, making caloric restriction-induced autophagy one of the most exciting, evidence-backed strategies for promoting healthy aging in both animals and potentially humans.